let's go select 1,944 number of visible people in a queue. So it gives us integer array heads, and each head is represent a person's head. And those person are on the indexes from 0 to n-1 from left to right order. And it says that a person is looking on its right, and he can only for a person he can only view a person which do not have for example this I can only view those J which um, which in the middle of the energy, all of the people between energy are smaller than J's height and I's height. So that means it cannot have a person greater than J's height or greater than I's height, right? So that he can view J. So let's look at the example. Um, we will see this person can see three persons, right? So this one is the first one, this is the second one. But he cannot see this person, right? Because there is a person which is greater than 0, 1, 2, 3, greater than head 3, right? The 2 is greater than 3. But he is able to view this person, the 4, right? So he can see 3 person. And also this person, the number 4 has a height greater than current this person, right? So we'll see, we can ignore the rest because this already been greater than current. So what we're thinking about is that let's look at the second example. So this person, you can see him, right? And you can also see this person. He cannot. He can just see one person, right? Because this already been greater than himself, so he can just see this person. And what about this one? This person can view this and this, right? And this is greater than himself. And this one can view this, and this person can view this, right? So to determine a person, for example, this person I, how many people he can view, right? So we will find what he can view is this is three, right? This is three person. And well, see, this is kind of a monotonic trends. So that means any person which has people and does not meet the which has greater than those has any people greater than J, right? Has been popped somewhere, right? So, for example, this J has has a person here which is greater than J. So this one is not valid. So should be pops in some cases. So intuitively, we think about use some monotonic data structure, so it monotonic stack, right? So we should keep in a monotonic stack. But the thing is that for each person, if we keeping a monotonic increasing stack, it's apparently not efficient, right? So what we think about is that we can do this kind of question in a reversed order to do a monotonic decreasing order. So let's look at the steps. How can we simulate the process? So the first person, when there is no, he's the first person, right? And there's no people in the stack. So he will nobody. So this is 0. And we put this one into into a stack, right? So this is the first person. And the second person, let's see, he is greater than the person who is has had hit in the stack. So he's able to pop it out. So when this person can be popped out, um, that means between the new person and the person in the stack, there is no higher one, right? Otherwise, it's already been popped. So he is able to view this person, right? So we'll add one result to him so he can view one, right? And there is when this one being popped out, there is no person being left on the stack, so he can only view one person. Let's look at the this one, right? So this person, because currently in the stack there is one person, right? And he cannot pop in anyone. That means so he just place himself into the stack. And because there is one person in the stack, so this will also add to this person's visible person, right? And let's look at this person. This person, he's higher than him, right? So he's able to pop this one from stack. So when pop, these people is visible to him, right? So add one. And this one being popped, right? And also what left on the stack is has greater hit, right? He is not able to pop this person, but he is able to view this person. So it will add another one, right? So there are two parts. One is the person who has been popped out. Another is the person who is left on the stack. So now there is this person and this person on the stack. And the new one person, the new one coming, right? He can only he cannot pop anyone, so just place him on the stack. He can view the next person, the higher one, right? So he has one. And let's look at the this person, right? He is able to pop this, right? If he is able to pop this, that means between um, between this and the new person, there is a new higher one. So he's able to add one, right? He's able to pop this, right? And add another one. He's not able to pop this because this one is higher. So he added to the stack, right? So there are two person, and because the stack there is a higher person, he's also available. So add one more, right? So that will be three. So this process is that we use a monotonic stack. We're keeping popping person. If we are able to popping, then that will be we add the visible to current new people, and also we are going to place this person into a stack. And after we before we check, we place this person into a stack. We need to check whether there is any person left on the stack. If there is any person left on the stack, we also add it to this person, right? So there are two parts. One is how many being popped popped uh, from the monotonic stack. Another is that if there is still person left, that is also visible to him. That will add one more, right? So let's convert this kind of process into code. We're going to have int n equals height dot length, and we can let's have this one result equals new int n, right? And we can use array to simulate stack equals new int n, and we can use the array and the index to simulate stack index set as -1. So what we do is that for int I equals n minus 1, I greater equal to 0, I minus minus. So we're checking, we're going to keeping a monotonic from the right to left monotonic decreasing stack, right? So we'll write while if there is any items left on the stack that is the index greater equal to 0. And normally we'll put index on the stack, but for this question, uh, we can just put the height. It is to keep things simpler, right? So we'll say if the stack index is smaller than height I, then we're going to pop. So we'll have pop. What is pop is just for the stack index decrease, right? So our result, I should add this part. How many people we popped out that will add to our result. And we're going to also stack index, add this person into the stack, right? Face. But before we add this person to this stack, we should check whether there is any person left. So if index is greater or equal to 0, our results I should add 1, right? So in the end, that's the return result. It is the O(n) time complexity with O(n) space complexity. Let's also write the Python code for this. So we're going to have n equals the length of heights, and we're going to have result equals multiplied by n, and we have a step. So for I in range n minus 1, minus 1, minus 1. So we're going to while stack, and stack minus 1 is smaller than heights I. Then we have a stack of the pop. And we also have result I. Every time we pop should add equal to 1, right? And also we need to put the current people into a stack before we put push. We try to see if it is empty. If the stack is not empty, and our result I should add the person who is left on the stack. And then we'll have a step append heights I. In the end, just a return result.